Okay. Hello, everyone. Thank you for being here. I'm really glad to see so many people in this session. And this is me. This is cross-platform mruby on Dreamcast and Wii. So I have my Nintendo Wii right here, and I have a GameCube controller connected. And let me start the presentation program. So this takes a while, but this is the output from my Nintendo Wii. Oh, wait, this is the boot menu. So there's one more step to go. Hey, I'm wearing the same design. So yeah, this is a familiar-looking logo on Wii, and this cross-platform mruby on Sega Dreamcast and Nintendo Wii by me, Yuji, at RubyKaigi 2024. And press A to start. So let's go. So table of contents. This is well, actually, this is not quite accurate because I kept on changing the contents, but basically I'm going to talk a little bit about myself, then mruby, Dreamcast, Wii, and then how mruby supports them, and about this presentation app I'm running right now, and why, and a bit about cross-platform development and differences and limitations summary, and I'd like to conclude with thanks and information, as well as a little demo game if I have time for it. So let's go. So this is me. I'm Yuji. I'm a software developer. I work at a Sydney-based startup called CipherStash, where we work on software systems that would let people protect data, not just systems. And I do things like encryption in use and tracking where the data goes. So what I'm saying is I'm not an expert in game consoles development, software development, as well as, well, I'm not an expert in data protection either, but anyway. I'm now based in Tokyo. I've spent a lot of time in Adelaide, Australia, and you can reach me at Yuji Yokoo at ruby.social, or you could reach me at Yuji Yokoo on GitHub and Twitter. So this being RubyKaigi, I guess a lot of people know what mruby is, but I don't want to assume assume everyone does. So mruby is a lightweight implementation of Ruby. And it's great for embedding into C programs. It doesn't have to be C, but it's the most straightforward option. And about Dreamcast, this is a photo of my Dreamcast. In fact, I have the unit right here, but I'm not going to lift it. And Dreamcast was the best video game console from Sega. And it was released in November 1998, so it was the last century. And it's 200 megahertz processor and 16 megabytes of RAM. It's quite limited by today's standard. But what's great about Dreamcast is that the indie community, or like indie scene and homebrew communities, they're really still very strong at the moment. And there are still commercial software coming out, and there's good free and open source software available for homebrew and indie development. And it's the most popular option is called CallistiOS. It comes with tools and libraries, and it's also known as Chaos. And Chaos has got a port system where a lot of additional software can be compiled and added to your environment. And now Chaos ports includes mruby. So you can just easily use mruby on Chaos now. And the great thing about that, especially in this instance, is that I did not do anything. Somebody else who was involved in that did all the work and got it into Chaos ports. So that's amazing. I'm so happy about that. It's great. And also, Dreamcast can run your custom code, your software without any hardware modification. You can just write a specially formatted CDR, and that would Dreamcast would boot that for you. And assuming everyone knows what CDRs are, I'm not going to go into that. And about Wii, this is a photo of my Nintendo Wii. This is the exact same unit that I'm using right now. And this was a great innovative console from Nintendo. And released in 2006. Can you believe it's 18 years ago? And it wasn't very powerful by the standards of the day. And what differentiated Wii from other consoles probably was the Wii Remote, also known as Wiimote. And I have one here, and in fact, my presentation software supports it. So what's great about Wii today? Well, Wii was extremely popular. Dreamcast sold over 9 million units around the world, and Wii sold over 100 million units. So I'm not saying Dreamcast wasn't very popular, but Wii was extremely popular. And what that means is there are lots of people who have a Wii collecting dust at home. And I was one of them until I started developing software for them. And about this application, this presentation you're seeing right now, it's called Dream Present. I started developing it in 2019 for Dreamcast. And originally, it ran on Dreamcast only, but now, as you can see, it's running on my Wii. So it runs on DC and Wii. But it's a Dreamcast version, Dreamcast presentation software, Dream Present ported to Wii. So it's not Wii Present, it's Dream Present running on Wii. And actually, it started with just a little game and the presentation app on Dreamcast. But eventually, I did more stuff on things like getting mruby /C on Mega Drive. And that whole effort received an Outstanding Performance Award at Fukuoka Ruby Award last year. So I'm very proud of that achievement. Thank you. And the main features of this app are text, image, and sound. Yeah, that sound. And also, it's a live demo, so it's running my code on the game console. So if it has glitches or crashes, you have to forgive me because it's a live demo. Something's got to go wrong, right? And so mruby support for Dreamcast and Wii. So Dreamcast is officially supported since 2020. By officially supported, I mean there's a build config file included in main distribution. So this was the pull request. Again, this was done by the person who also did a lot of work for adding mruby to Chaos ports. And this person made a pull request to mruby, and build config was added to the main distribution. And we, since October 2023, build config for Nintendo Wii is also included in mruby. And this was a pull request from me. And you should be able to run this command for Dreamcast and this command for Wii to build mruby for those platforms. Of course, you need tool chains and libraries and everything in your system. So that's a separate concern. So you might be wondering why I'm doing this or why you might want to do this. And that is a great question. Let's leave it there. So Dreamcast and Wii, they compare, they're quite different in many ways. Dreamcast uses SH4 processor, and Wii runs a PowerPC. And of course, they come from different generations, even though Dreamcast was relatively powerful and Wii was not powerful from respective generations. Wii has got more memory, processing power, and graphics capabilities. So usually it's easier to port something that runs on Dreamcast to run on Wii than vice versa. And of course, the software stack is different. The libraries and tools, you have to prepare them separately, and they are not the same. They work in many different ways, and they both have free and open dev kit and SDK, and also they both come with GCC. That is great news for anyone who wants to work with mruby, because mruby, well, as far as my experience goes, some environments don't come with GCC or any popular compilers, and they're very, very difficult to work with. And they both allow running your own code easily. As I mentioned, Dreamcast, you can just write a CD and boot it. And for Wii, like I've got here, I have added software that would let me boot from an SD card using an exploit that goes through the messaging app of Wii. So what I did was save a specially formatted message on an SD card and open that message in a message application on Wii. There are also other exploits, like you can point your DNS config at some DNS server that would that would let Wii go to a server that would provide the exploit. So it's quite easy. There's absolutely no hardware modification on my Wii. And when you write when you write mruby code for both Dreamcast and Wii, you have to write some C and compile the mruby code with mrbc, and then that makes the bytecode, and you put the bytecode and C code together, and you cross-compile using the tool chains from the SDK, and that would make either SH4 or PowerPC, depending on which platform you're developing for, object files. Then you link the Dreamcast or Wii library as well as mruby library, which includes the mruby runtime, and that would make an executable. But this is executable, but usually from this point, you do one more step to produce bootable images. And in the case of Dreamcast, you can write it onto a CD. And in the case of Wii, you can put it on an SD card. And for making things cross-platform, I considered using MRB gems. MRB gems is a thing in mruby that would let you add and remove features at compile time. And I was thinking about maybe I can just link all the platform-specific libraries and dependencies into MRB gems and have my main source free of that stuff. And I couldn't figure out how to fix some issues, so I ditched that idea quickly. And instead, I started doing manual management of having separate source folders. And I started this presentation on Dreamcast. Then I ported it to Wii, then also brought it back to Dreamcast so that it runs on both platforms. And so this is what the source directory looked like originally. There was one makefile, one source directory, and there was one asset directory. And when I ported it to Wii, it stayed the same, but the contents of makefile and contents of C source files and some of the Ruby source files changed. And by making it build for both, I split the makefile to two separate makefiles, which isn't great. I'm intending to address this, but also the source files have been split into Wii directory and Dreamcast directory. They both contain C files as well as some of the Ruby extensions for each platforms. And this is just a bit of C code just to show you main entry point. So this is a main function in C, and the top half contains some Dreamcast specific initialization things, and the bottom half contains loading mruby and starting. And this is the same thing for Wii. And the bottom half is exactly the same. The top initialization bits have changed. This is, of course, it's a little bit simplified, and there's a lot more going on, but this is the general idea. So a lot of things have different API calls and different constant names or whatever, but a lot of stuff often look similar between two platforms. And this is the main starting point of the main presentation application. This is just plain Ruby code. And there were some notable differences I had to overcome or work around. And Chaos provides ROM disk for the assets, so it's virtual file system. You can treat it like a file system. It comes with Chaos provides file open function, so you can treat it like almost like a regular file. Whereas when you use devkit ppc on Wii, it converts the assets into an object file and a header file. And when you in your program, they are available as constants. So for that, because if you're using file name as to identify your assets, you need to map the file name to the variables for Wii. And another notable difference was the graphics API. Chaos, well, because this was where I started and it was simple, I simply used the VRAM access on Chaos. What that means is every pixel has a memory location, and I can just write RGB values. And this works great for things that doesn't require any performance. And it's actually quite simple to use. But for Wii, I started using grrlib, which provides things like PNG file support. And what this library requires is calling graphics drawing functions first, then call render. And at the time of the render call, it puts stuff on screen. So the difference between these is with the VRAM-based approach, you can just draw whatever you want on screen whenever you want. Whereas if you want to add something in the bottom approach, at the time of render, you lose all the history all the drawing objects you've added. So you have to call the existing objects on screen and the new drawing function to add something new, and then call render. So they work slightly differently, and neither approach is better or worse. But the top approach is a lot simpler and doesn't perform very well. And in fact, I tried to implement the same style using the VRAM-based approach, the software rendering, and it was a bit slow, so I decided not to use that. And other differences, particularly something to note, is that Wii Remote isn't available on Dreamcast. So, well, I will show you exactly how I ported this motion gesture to Dreamcast in a minute. But this is a big difference. And also, there was a bit of an issue that I couldn't really figure out with clock, so I ended up implementing another function that would just take the tick from the boot time and convert it into milliseconds because I could not figure out how to work with the clock on Wii. And testing and debugging, that's always a problem with this sort of stuff, especially when a bug only happens on the actual device and not the emulator. And emulators often have console output and lets you do printf-based debugging. But when something doesn't even give you any output, it wasn't very often, but I sometimes encounter bugs like that, and I ended up doing go to the known good version and then go halfway to the broken version and then binary search, a bit like bisect on Git, but sometimes it was just a chunk of function, like 50-line function, and identify where the breaking calls are. So this is just a screenshot of me using a emulator on Dreamcast emulator on Linux VM from years ago. This is one of the early versions of this presentation app. And now, with this cross-platform development, I'm facing a new problem. I'm debugging on two platforms. So I don't know what I can do about this. It feels like what people used to joke about Java. Write once, run anywhere, or write once, debug everywhere. Here you go. I accidentally swung the remote. So in summary, cross-platform mruby sort of works, but the DX is quite rough, and the often platform-specific stuff resemble each other, but there are notable differences, and debugging is hard. And possibly when you add a platform that would multiply the debugging effort. And I would like to thank mruby developers, CallistiOS developers, and DevKit Pro who provide DevKit PPC, and great Dreamcast developers at Simulant Game Engine Discord channel, and RubyKaigi organizers and sponsors, and everyone who came to this session today. Thank you. Oh, wait, sorry. This still continues. So there's a little demo game I developed. Oh, wait, sorry. There's URLs, but if you go to this, if you read this QR code, you should be able to find the links to the things I've done with video game consoles. So there's a little demo game. So here's a demo game I developed. It can be played with the Wii Remote, but unfortunately, the response is very poor. It's not very playable. So let me play with the controller. This is a lot better. So now, this is Nintendo Wii. Now let me switch to Dreamcast. Since I mentioned I was going to show you how I worked around the problem of how I ported the motion gesture. So this is a hardware modified Dreamcast, and so here's the Dreamcast version of the presentation. And yeah, it's unofficial, but this screen cannot be skipped. So it responds to my controller press. It works much the same way, somewhat different colors and different font, but it's a cross-platform mruby right here. But as I said, motion gesture is not here, right? Without it, it cannot be truly cross-platform. I developed this technique of swinging this controller and pressing the button at the same time. Here, yeah. Okay, I disconnected the controller accidentally. Okay, but no, that's just cheating. So I actually re-reported the motion gesture feature. And you might be wondering how that was possible, or some of you might know what I'm about to show you. Did you know there was a fishing controller for Dreamcast? This fishing controller comes with a reel as well as a motion sensor. So what that lets me do now is this. See, so this brings the user interface truly in line with the Wii version. So thank you very much, everyone. This is cross-platform mruby on Wii and Dreamcast.